In part 2 of completing the square, we are going to look at how can we take a quadratic equation in standard form, which is ax squared plus bx plus c, and how can we convert it into the vertex form, which is a times x minus h squared plus k. The way we go from standard form to vertex form is by using the completing the square technique. Sometimes we'll want to change it from this into this so that we can more easily find where the vertex of our parabola lies, because h and k are the x and y coordinates respectively of our vertex. So let's see what we can do to change standard form into vertex form. Here we have x squared plus 10x minus 13, and our goal is to take this standard form quadratic equation and change it into vertex form. In order to do that, first I'm going to move this minus 13 off to the right a little bit. If you were doing this on pencil and paper, well, you really can't move it too easily without erasing, so you can either erase or just rewrite it. But I'm going to move this guy off to the side. The reason why I've moved this guy off to the side is because I am going to complete the square with my x terms. That way I have a squared binomial that has been condensed. So we'll start by doing our completing the square technique. We'll take our b, which is the single x term. I have 10. Cut it in half by dividing by 2 and square it. That's going to give me a plus 25. Okay? As we saw in the part 1 video, by adding that 25, I have unbalanced my equation. But I don't have an equals sign this time to just add 25 elsewhere. So in order to keep our equation balanced, since I added 25 here, I am going to subtract 25 out there. By adding 25 and subtracting 25, as we see there, I really have changed the equation by nothing. It is a zero-sum change. So we can move on. I'm going to condense my trinomial to be x plus 5 squared. And then the minus 13 minus 25 is a minus 38. And I'm done. This is my vertex form. X plus 5 squared minus 38. If I was going to write down what the vertex is, which if you're putting it in vertex form, someone is probably asking you to do that, your vertex is going to be negative 5. It's the opposite of what we have here. So here is a plus 5. We want the opposite, a negative 5. And then minus 38. That is our vertex. Not too bad, but we'll try another example, see what happens. But if you are good and strong with completing the square, changing a standard form quadratic equation to a vertex form is really not that terrible. Alright, let's try another example. Alright, here we have 2x squared minus 8x plus 3. It is a standard form quadratic function, and we want to change it into a vertex form quadratic function. Just like we did in the first example, we're going to take our constant over here at the end and move him off to the side. And we're going to focus on this right here. We are going to, before we start completing the square, we are going to factor out the 2 that these share. That's going to make life a little bit simpler for us. So if I factor out that 2, I'm going to have x squared minus 4x. I still have the plus 3 over here because I did nothing with plus 3. But now I can complete my square. I'm going to take the minus 4 that we see here, divide it by 2, and square it, which will give us a positive 4. Once again, my equation has become unbalanced because of adding that 4. So I'm going to have to subtract something from the 3. And what am I going to subtract? At first we might say we're going to subtract 4 because we added a 4. But if you watched part 1, you'll know that we didn't really add a 4. We added a 4 times 2, which is 8. So we have to subtract 8 from the 3 to keep our equation balanced. Now we can condense. So we'll have 2 times x minus 2 squared minus 5. And that's our vertex form. We have everything taken care of here. I have my piece on the inside, my perfect binomial, and I have my piece on the outside. This, too, does not play any role in finding our vertex. Our vertex is the opposite of what's with the x, so it's a negative 2, so we have a positive 2, and what is outside the parentheses? A negative 5. There we go. We have successfully taken 2 quadratic functions, completed the square, condensed them down into the vertex form, and found the vertex. That's it for this video. Short and sweet. Hope you found it useful, and good luck.